Hi, everyone. My name is Murat. I'm a staff engineer and test architect at Extent, and I believe Cypress component test-driven design can take our front-end engineer to the next level. We'll talk about a TDD example, go through a component test. We'll talk further about component testing, a second example. We'll cover end-to-end testing within the context of TDD. And finally, we'll wrap up with recommended best practices. The application on the test is Tour of Heroes from Angular. You're all familiar with it. It's rewritten in React and the book, Cypress Component Test-Driven Design. You'll be able to find the link to the book right here and the final app with all the source code, everything in this presentation over here at this link. It's a React application with a JSON server, some nice tooling. We have many Cypress Component Test examples here. Each one of them has a React testing library mirror. You have UI integration tests, stub in the network. You have API end-to-end and UI end-to-end tests. Proportion of them is 1 to 5 to 15, which gives you an idea about the test architecture. Here's our first component. You can find it in chapter 3 of the book and final code right here in this link. Start with a placeholder test. First, you want to make sure that you can render something. You imported the right file. You have the styles. This is a good baseline start. You just copy paste this to every starting component test run. So you have it that being rendered. Nice. Write a failing test because with TDD, you have fault finding tests for things that matter. So we want a link that has an attribute that goes to react.js.org. And we have our first failure. Great. One little test failing, and we try to make that work, adding a link with an href. Want to start with something with failing, want to do the minimum to get it to work, and then you want to try to make it better. You want to use component test as the design tool to aid your red-green refactor cycles. We're not seeing anything being rendered. So we think, okay, here's an idea. Let's make sure that this is visible. So we add a failing test. Now we have a red. Incremental visual enhancements mean you can use the visual feedback that's not up to your expectation as the red indicator. So I'm not seeing it. I want something in there. I'm going to go and add an icon so I see a decent render. Something being visible doesn't really help, but I want to see the right thing. The obvious but hard thing to do with TDD is write very small incremental tests at a time. You want to build the component iteratively using tests. You want to find out more about it with the tests. Like you're ad hocking, but as you're ad hocking, you go ahead and add a step. So we have an attribute, we add a test for it, and then we add that attribute check. We write another step of test, and then we add another attribute to make that work. At the end, we think, okay, maybe we need an icon right here in this component. We add that data size selector to the top tag of the component, which I recommend makes the component very easy to find when it's used as a child or when it's used in end-to-end tests. So we do that. And then under that component, we're expecting an SVG to render because that's the icon we're looking for. If you have TypeScript and ESLint, this kind of tooling can also aid your red-green refactor cycles. Here, the property 2 is missing. Navlink is from React Router DOM. So we don't really have to have a failing test for it. And so we can just add that attribute right there. In order to make the test work, on top of that, we have to wrap it with a browser router because that's how you mount your component when you're using React Router DOM. We just wrap with a browser router. You have to always remember a component test is a small scale application. So you have to replicate your application wrappers. You're using browser router in the main app, then you'll be using browser router whenever you're mounting your component. But your application may be looking like this, and your test mounts will be looking like the one on the left. No problem. You can write a custom wrapper function. You'll be able to find the link here, and you'll be writing one in the book as well. And it's just a one-time thing. If some of your components don't need to be wrapped with some of these, that's perfectly fine. Extra wrappers do not really change how the component behaves. The component just uses whatever it needs. It's the exact same thing you would do with React Testing Library. You can also write multiple different kinds of custom wrappers, right? Some of the wrappers for these components, but different wrapper for another set of components. Back to the test, we want to add a link that has 3 spans under it with some strings. So you write a failing test for it. And then we get our failure because we don't even have that navlink data size selector. So we go ahead and add that. We add some classes to make the render look nice. We have our spans. Each one of them just has a hard-coded text. And we have a nice passing test at the end. Renders the way we want it to. The question comes up, should we break down the test or not? On the left and right, it's the same exact test doing the same thing. Left side breaks it down. Right side just does one flow. What matters is the beginning state of a test. If reaching this state is common, then in my opinion, the right side, an opportunity for a test enhancement is stronger. I prefer the example on the right. So long as tests don't duplicate though, they're order independent and stateless, either side is fine. The reason unit testers may prefer the one on the left is because they want to have a smaller blast radius. This is not a problem. You have a Cypress test runner. It's very easy to find exactly where the failure happened. You just have to be careful not to do the thing on the left. So here we have 3 if blocks. They overlap with each other. So the first one's covered in the second one, and the third one covers the second one. So this is just one test. You can just write one test, mostly the third one, with the visibility check from the first test, and that's good enough. So an example of what not to do and what to do. Here's the comparison to a React testing library. One-on-one is the same thing. You can translate each line. The intent is always the same. The difference is the API style. So you have async await, variable assignments on one side, and you have a chain syntax, a little more flow on the right side. But the intent, your actions, whatever you're doing is the same. Just different ways of doing it. So that was a walkthrough of a TDD example with component tests. Now we'll have a second example and some more pointers about component testing, especially about props, wrappers of components, and parent-child relationships. So this example is from chapter 5 of the book, and here's the final code. You can use hard coding initially, or you can use console log to make your test pass. Just hard coding, everything's fine there. Then you manipulate your component either with props or wrappers. So here we have a prop. Instead of a hard-coded test, we're adding that prop right here, the placeholder, and then we add it to the component. We can pass data with props. Right here we have a prop for heroes. We're passing an empty array. And then here we're passing a heroes array. On the right side, on the top, we're not passing anything, just the component by itself. But if you wanted to, we could have a wrapper there versus context API, and thereby provide a value there, the villains array, and that's how we manipulate our component. So either you use a property or wrapper. That's how you customize your component test in Cypress and React and anywhere else. When you're adding props, you add the property. Right here, we're adding the name property, and then you add the prop to the component types. You add it to the arguments of the component, and you use it in the component. Same flow, we'll be going through it. This time we're adding the value property, a test, failing with that, right? And then add the prop, the argument, and use it in the test itself, which is in the component. And we have a nice render at some point, which we'll be using for a form. This form, we want it to have the ability to be a read-only also. So you write a failing test for that. Go ahead and add the prop. And if we have events, we can just stub them. Here, we have an event that's 2 keystrokes. So we want the change event to be called twice. First, the failing test, and then we add the prop, the argument, and again, we use it in the component. We want to seek failures through tests. And when you have green tests, you want to prefer adding more tests or refactoring versus adding additional source code. This is very important. Sometimes you have a passing test, and then we go and add so much source code. No need to do that. A little bit of a test, make it work, make it better. If you have something working, you want to prefer adding more tests. You want to have a failure first or refactoring before you go to the source code. Here's a parent-child example. So this is a child being used at the parent, 2 different varieties, a name and a description. Always check if you're duplicating the test effort covered elsewhere. So you want to find opportunities to cover different functionalities. On the right, we already have a check that we're typing something, and then that thing is visible. We're duplicating that test over here at the parent, and that's not good. But at the parent, you can do something else. We can check that the parent renders 2 variants of the child. Here's another advice. With JSX and template literals, you can be pretty creative about your selectors. I like to have a data site at the top tag of the component, and if there are any variants, I just exploit JSX and template literals, and it's pretty fun. React testing library versus Cypress component test. I think for this one, the main difference was the how we do the unchanged event test. On the right side is scigget, the change tag right here, and then checking the call count. And on the left side, so just fn instead of a size stub. Then we check that it's been called so many times. Doing the exact same thing, every step translates, slightly different style. We went through TDD example, component example, two component test examples, some best practices over there. Now let's look at TDD with end-to-end tests. So end-to-end tests are great when you finished building your components. Now it's time for routing, state management, application flows, components talking to each other, or the backend. That's time for E2E. But remember, you want to aim to test at the lowest level and then move up when you cannot test confidently. This is an example of that. I can't do anything about routing when I'm working with components, right? I need end-to-end tests. So first you look at the child. Can I do this at the child? Nope. Then you move on to the parent. If that's not enough, you have a UI integration test. You stub out the network, but your components are talking to each other. And maybe you need the backend. Maybe a component is making a backend call or something. Maybe you can use end-to-end tests then. Routing feature with TDD example. So this is an end-to-end test. We're using TDD. It's from chapter 13. And it's the final code of this test. You always want to remember what you're doing at your child component. So here we're visiting the component, we're visiting the application in an end-to-end test, and we're making sure that header bar component is displayed. So how do we modify our application so that the header bar component is displayed? We go ahead and take a look at the child, the header bar, and there we're using browser router and wrapping the header bar. So our application is going to also have to do that. So you can cheat and always look at the component tests that you already built. They'll make your life easier when you're writing your end-to-end test or when you're writing other component tests. You'll be having the selectors already there, data size selectors, and you can always refer back. It's documentation for you. What do I do with this thing? The TDD flow is exactly the same with E2E. You want to start with something failing. You want to do the minimum to get it to work. So just minimum, add the navbar component. And then if you can make it better, do refactoring. Once things are working, prefer to add more failures. You want to have a not found route, and that should display a not found component, right? First the failing test, and then we add that not found component, do the route configuration, and we're finding out more about the application through testing in this way. If we have passing tests, we want to add tests or refactor before adding more source code. We have that passing test. We add that additional check for location. We're still green. So, okay, then we can think of another failure. You want to seek these failures. Failures are great when you're doing TDD. You want to keep adding tests until there's a failure. So that's very good. Once you have that failing test, then you can add the new feature. So here we're visiting the heroes path, and we want heroes component to be displayed. That's our failure. To make things work, we just add that feature. We say, okay, at the heroes out, we should be rendering that certain component. And that's a TDD example using end-to-end tests for routing. Let's go to the recommended best practices. There are a few of these, so we'll go through each. With API end-to-end tests, don't do naive UI end-to-end testing before you have confidence that your backend works. You want to use an API test client instead of using your UI client as the test client. This way you can test earlier in your deployments. You want to be aware of the test suites of your backend, and you want to avoid duplication. You want to use modest amounts of E2E and do a targeted gap filling when you have UI end-to-end tests. And you don't want to have to repeat this UI end-to-end test if you already have confidence in one area. For instance, login works. Then try not to do the same login in every test. Maybe you can go through the back door or have another way of logging in. When login doesn't work, only one test is going to fail, and you know it's not working. Not everything has to fail. Here's your API end-to-end test strategy for CRUD. So it's creation, create and delete, update, create, update, and delete. And to be able to delete, you have to create something. But look at this. Update covers every single flow. If you test update, creation and delete are already covered. So just test update. This is the backend example. You can find it in chapter 15 and the final code here in this link. We are adding a hero, the post request. We make sure that thing got added, make an assertion. Then we go ahead and edit it, we update it, and then we make sure that whatever we updated did get updated the way we wanted it to. Then we make the removal and then make sure that it's removed from the database. Good example of an API end-to-end test. And you want to have this where the backend code lives, closer there if possible. UI end-to-end on the other side is very similar to API end-to-end, but instead you can use the API commands that you already created and isolate the UI tests. For instance, if you want to test update, you can see the database with the API command that we already wrote. You can do your UI testing, and then at the end, you can delete. We'll go through the simple creation example, but you get the idea. So we'll be first doing UI create, and then we'll clean up with the API. Here's that test. We'll go through also the UI integration test. The first ones are canceling and refreshing, and they're not really using the real network. The final one is going ahead and adding a hero, and after adding it, it's making sure that hero is on the list. And you can find the full test over here. In chapter 17, we go through this in the React query chapter, and here's the final test. In the beginning, we just navigate to that hero. We want everything to settle. We are using the real network, no stubbing here. We are at the right location. We do the UI creation. So we fill out the details. We hit the save button. And then we make our assertions that we're at the right path. The hero that we added is displaying there. And then finally, we do the API delete, like we saw before. The thing to watch out for is each one of these steps can be lots of development, right? So with API end-to-end testing, when you're doing TDD, you don't want to go even smaller because one line of end-to-end test can cover lots of source code. So this is the main idea from here. Keep end-to-end tests even smaller when you're doing TDD. What is UI integration test? So you want to always evaluate if you need your backend to gain confidence in your app's functionality. Only use real end-to-end tests when you have to have this confidence. And you shouldn't have to repeat that cost the same end-to-end test everywhere. Be aware of what your backend is already doing, and that makes your UI end-to-end concerns even less. So be careful not to duplicate and try to gap fill. You can judge people by what they don't do, by the cost of the things that they don't delve into. This is especially true for engineers, quote by Nietzsche. Let's convert a UI end-to-end test to a UI integration test. So we have two tests here. One of them testing refresh, the other one testing cancel. Using the real network, we're just waiting for the network to settle before we go ahead and check that refresh button does the refresh or the cancel button does the cancel. We already have an end-to-end test that's adding a hero and checking that the list is getting updated. So we don't really need this get request for real. Right? It can be just stub data. So we use a JSON file. We say anytime you hit that route, instead of the real thing, use the file, and there is your data. To be able to test refresh confidently or cancel, you don't need the backend. It's a perfect use case for a UI integration test. When you have errors, you want to test your error cases. Any test that's covering the positive flow with site intercept is a good branching spot. You want to try to test at the component level. And if you cannot test something, a negative error case scenario there, you want to move off to UI integration test. So here this is our positive scenario. You hit the save button and we expect a post request is going out. There's the perfect spot to do an error test case, a non-200 case. So we start with a 400. You also add a delay and make sure that there's a spinner at first, and then we get the error. It's from chapter 18 when we cover suspense, error boundary, and concurrency. So this test by itself just covers the use case for suspense and error boundary for this particular component. Want to avoid testing implementation details. You want to lean more towards black box testing while you're testing your component. And this is the same idea from React testing library, which is using mock service worker to do the same thing that we're doing with Cypress intercept. So on the left side, we have implementation detail test, testing that use state is being called, or React query is being called, or our post hook, our custom hook is being called when we click the save button. Instead, you want to test the consequences of clicking the save button. At the end, a network request should be going out to the backend. And it's better if you check this because if you change your implementation, this test is still going to work. Doesn't really matter how you do the internals. Mock Service Worker and Cypress Intercept are very comparable. Here's my comparison, one-on-one. You can check the links. In my opinion, Cypress Intercept can make things a little more succinct, a little more flexible, but you do your own research and let me know what you think. You want to take advantage of the visual feedback of the component tests. So here in chapter 8, navbar, I'm writing the book and I thought this is a good test. But when I serve the component, I see that every single link is highlighted. Okay, I click on each, I go to the right link, fine, but there's a defect. This means visually, when you see the component, this quality of the feedback improves your TDD, inspires you to check for more tests, and lets you detect these defects before they may even happen. You get a feedback from the CLI tool, but you have to be very careful. For me, it was way easier to see the visual thing and think, okay, when I just click on something, only that guy should be highlighted, and the rest should be not highlighted. So I added a test for that. The best part is ad hoc is possible in a component test. So you can just run the component test, and then your component is there by itself without reading any of the rest of the application. You can go and click around, look at DevTools, look at your extensions. It's just next level experience for a developer when they're working on a component in isolation. It's just mind-blowing, this technology. Here's the final test for navbar, RTL versus Cypress component test. Again, different styles, same intent. Cypress may be shorter, sometimes less code because of all the other packages versus jQuery that it comes with. So it's easier to unselect or get the ones that are not selected versus the other API and React testing library is the same way of doing the same thing. If you cannot use visual tools and you want to do TDD, my advice is use Wallaby. I'd go for this tool when I'm testing the backend, especially. But if you cannot use visual tools, too hard to migrate, check out Wallaby.js. It will give you inline feedback as you're writing your tests. And that's the pinnacle of TDD, which you can have from a CLI or IDE tool. Right? If you can't have visuals, have that at least. You can use combined coverage to make sure your TDD was successful. So we go through that example in the appendix in the book. We get coverage from Cypress component tests. We get coverage from Cypress end-to-end tests. And we get coverage from Jest and React testing library tests. This means you don't really have to migrate from React testing library to Cypress component testing. You can already have tests with Jest, the old test maybe, or the non-component test. Maybe you're testing your reducers or whatnot. You can just combine the coverage. And at the end, getting close to 100% coverage is not a challenge anymore. It's so easy. I've been doing this in multiple projects with JavaScript or TypeScript, doesn't matter. Combined coverage is the way to go. And it's not a be-all, end-all measurement, but if you have 100% code coverage, no one is going to say they're not confident in their application. What have we learned? The quality of the feedback with Cypress component testing improves TDD, component engineering, and early defect detection. Once you move up to routing, state management, and other complex things beyond components, TDD with endpoint tests is more relevant. With TDD, the key idea is to start with something failing. You want to do the minimum to get it to work, and then you want to try to make it better. Here are the links and references, the book, the final application, and the inspiration that contributed to this content. Thank you very much for listening. You have a nice one. Bye.